Well, guys, welcome to another episode of Xah Talk Show. Welcome to another episode of Xah Talk Show. We are going to code geometry today, geometry animation. We are going to code what's this called hypocycloid and epicycloid. So you see these curves. These are rolling circles around another circle. And let's just copy the code and let's start Wolfram language. Let me show you guys. So we just gonna code it, and if you are into mathematics, geometry, or if you are learning calculus, you might find this interesting. Otherwise, it's probably boring for you. Okay, coding session of Wolfram language. Now let's magnify. So here's a code. Shift Control N to make it typeset. Fantastic. Okay, 150 is probably too large. 125. Okay. Now Shift Enter to run it. So you got so it's plotting all these curves. These are called epicycloid. Okay, there they are. And what we're gonna do today is actually generate animation of one of them called Asteroid. This one, red. Okay, this one, 4 cusps, like asteroid star. Okay, we're gonna code that. So if you are watching this offline, play at 1.5 speed. If you are watching live here, say hi. Love to see your comments. Okay. So you are looking at Wolfram language. So by the way, let me do 2 minutes intro. Okay, so Wolfram language, you just search for it. You search for Xah Lee, download Wolfram Engine, Xah Lee Wolfram programming language, Wolfram language for programmers on my website, xahlee.info. Okay, then you will find the download link. You go there to download it. It's free. It's like 4 or 5 gigabytes. It's huge. Okay, Wolfram language, and then you can download. Okay, then you can download. Just read my articles. Okay, so I got this website, Wolfram language for programmers. You got the download link. Then you can go to difference between Wolfram language, Wolfram Engine, Mathematica, Wolfram script. What are they? Description. Then you go there. Then you also want to download the Wolfram Research, Wolfram language for Jupyter, so that you get this graphical user interface. Otherwise, what you get is a command line terminal. Okay, so that's an introduction to get Wolfram language. So let's start just to do this. Okay, so what I want to do today is this one. Okay, so yeah, do we have enough intro? Yeah, so I want to do the asteroid. Okay, so let me go to it. So, and also this is my website. Search for Visual Dictionary of Spatial Plane Curves. You'll find my website, xahlee.info there, XAHLEE. Okay. And my website haven't been updated for the past 20 days because there are some issues, but that will be fixed soon. So anyway, you go to my website, then you go down. So we're gonna do today this one. Okay, so we're gonna generate this. We're gonna write code for this one. Rolling a circle around another circle. The smaller circle is 1/4 the size of the larger circle by radius. Then if you put a point on the rim of the circle, you'll trace out this curve. It's called asteroid. And it is a special case of what's called hypocycloid. So you see all these are hypocycloid. This kind of curve in the toy market is known as spiral graph. Okay, because they market that toy about 50 years ago. Anyway, so we're gonna code this animation. So this is about Wolfram language creating an animation, and what effectively you need to learn is that you're gonna draw a graph. You're gonna draw a list of graphics. So you're gonna draw a sequence of graphics. Then you can then it became animation, because animation is just a list of images. Okay, and the key to know is that you want to draw a circle, then you want to draw a smaller circle, and you want to know at each graphics where to position the circle and where to position the dot. That's the essence of what you need to know to create this animation. Okay, so that's intro. So let me just drink some juice. This is like guava juice. Fantastic. And this is red wine. Fantastic. Okay, so let's see. Let's begin. Okay, let's begin to do that. So close that. So I want to copy the link. Today's talk show. Paste the link there. Linkify. So Asteroid. Okay, Asteroid. And we show in browser. So we go to Asteroid. We want to generate this code. I already have the package. Now, if you don't know, just search for Xah Lee Wolfram package. Okay, GitHub Xah Lee Wolfram package. You can actually go to either one of these. I got several packages on GitHub. So GitHub Xah Wolfram mode. Go to my homepage Xah Lee on GitHub, and plane curve generator. So there. So this package that's for Wolfram language. Turn on JavaScript. You can find the code for this asteroid. So for that. And for that, it's already done. So you can just grab the code from this GitHub plane curve generator. Okay. But what I want to do is to extract it and update the code, because those codes are written like almost unchanged from 1997, 30 years ago. So we're gonna update it, refresh it. I'm gonna show you how to do it. Okay, so let's just go to my Git, search for generate plane curve generator. That's the package, and let's delete the Emacs backup. Okay, delete them, refresh. Okay, now let's those are images. Okay, open, next, 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 next. We did this yesterday. Was it? We did this. Well, we did that yesterday or 2 days ago. Okay, so the one we want is go there, search for asteroid. Okay, so let me just do it. Let me show you the code in a moment. Okay, not asteroid. So search WL. WL is the file name extension for Wolfram language. Okay, that's a bunch of examples of Wolfram language. Okay, that's the one we want. And so search for, okay, search. Okay, it's actually here. Okay, it's defined in terms of this function, hypocycloid. Okay, so we just gonna copy that. Hold on a second. So we're gonna go to envelope. We're gonna create a code here. Okay, hypocycloid. Yeah. Yeah, we're gonna create Wolfram language code here. Yeah, and so syntax correct. Go to the browser, refresh. You can see we started to have the code there, and the code is going to be, of course, not just that, but let's go back to the package. Close that. Yeah, here we want to know the code is actually that. Okay, there. Okay, so it's okay, so there. Okay, now we don't need that anymore. Let's go back to our code here. Okay, put it back, syntax correct, showing browser, asteroid page, go down there, rolling a circle there. Here's a code. Okay, now will that code run? Yes, of course. But we want to improve it. But before we do, let me just show you. Let's just run it. Okay. So it's the code is independent. So any person see this code, they can just copy it and run it in Wolfram language. Okay. So let's select all, paste, Shift, Control N to show typeset. You see, fantastic typesetting with automatic line management. So you don't like formatting, code formatting. You can see there's an indentation. There is line wrap automatically. You see it's controlled automatically. Okay. Now Shift Enter to run it. So it's done. It's done. All you have to do is just actual call the function. So that's the function name. Shift Enter. No, it didn't work. Why? Because wait, Astro generated two, not three. What was it? 2 or 3? So two. Okay, so why I copied it wrong before? Why do we have 3 there? 2. Shift Enter. So there it is. It generated a bunch of images and now go all the way down. So each one of these is image. You can export as graphics. Now what we want to do is that, but we want to animate this list of images. So you just say list animate. Okay, add, Shift Enter. There it is. There it is. Okay, fantastic. We got a code. Now the job now is to optimize the code. Okay, so now it's about very technical details of Wolfram language. How do you like coding, Wolfram language coding, very technical details. Okay, and so if you we already explained how to generate this image. Like all you have to do is like you need to know at each frame, like the mathematically you need to know at each frame where is the position of the circle and where is the position of the dot. You just draw the dot in the circle. Okay, but how do you do that in Wolfram language? Okay, that's what we're gonna dive into. And so it's gonna be, from now on, it's gonna be very technical. You guys, so if you are still interested, you can keep watching. Okay. Okay, so so this is like, okay, very technical Wolfram language stuff. So let me just do that. So Asteroid version 2. So why did we get this 3 shouldn't be there? Okay, that's a mistake. Now, do that make sense? That makes sense? That makes sense? Anyone, everyone? Okay, Astro. Okay, so there's a Astro generator 2. I see. So there is. Okay, so 2 and what is the 1? I forgot what is the 1. Let's just let's just code it. Yeah. Okay, let's create a new window. What Okay, the first one, that is the tremor of Archimedes. So we don't want that, okay? We don't want the tremor of Archimedes, okay? That's the first one. The second one, animation, is a special case of hypocycloid, okay? That's what we want. And the third one generates animation that traces the curved asteroid showing that is the envelope of coaxial axis. Okay, that we don't care. We did that yesterday. So we just want the second one. So do we have like this inline documentation there? No. So this, let's rename the function because I don't want it because this hypocycloid generator, it is a special case. The asteroid, now remember this asteroid, this curve we are doing asteroid, it is a special case of the hypocycloid, you see. So hypocycloid means you roll a circle inside a circle. They are all generated by rolling a circle inside a circle. Okay, the curve they create is all called hypocycloid. So the asteroid is just a special case of hypocycloid. So now we don't need, we don't want actually, like we don't need, let's just delete this. So actually this is what you want. Okay, so delete that generator search. Delete that. Okay, so let's just improve the code. That's what we're doing. So let's rename it hypocycloid animate. Okay, let's rename it hypocycloid animate. Okay, that's our new name. Okay, and okay, hold on a second. Then these options, we don't want that because we are not writing a package. So we don't want the options. Let's just remove. So this options is how you define optional parameters. Okay, delete that. Now we just going to, okay, we just going to yeah, so this is a parameter and this is this is 0 to 2 pi in steps of 2 pi divided by 80. Okay, that will create 81 frames basically. Delete that. Okay, so this is a function actually you want to write. Okay, there, clear. So let's start to clear that symbol name. We start fresh in case it's already defined or in case we need to re-evaluate it. Am I doing good? Say hi. Okay, if you enjoyed watching this, thumb up my videos, show it to your friends. Okay, because I don't do dramatic shit. So if you like my stuff, show it to your friends and thumb up. Okay, so we got we writing again Wolfram language code. Okay, a little drink red wine. Let's finish it. Again, the code, the goal is to have independent code. So it's gonna be just 50 lines, actually like 40 lines of code. so people can directly copy from the website, like copy and paste in Wolfram language or Wolfram Alpha. It will generate the code. You don't need to look for like, where do I download the package? How do you install the package in the Wolfram language init directory? Where is the init directory? Things like that. Like, or Python, like how do you install a package in Python or JavaScript? Do you need npm? You don't need all that. Just copy the code, paste it, run it, it'll work. Okay, because the code is not too complicated, like 30 lines at tops. Okay, so that's what we are doing, writing this animation, and I'm doing going through them with explanation. Okay, so first of all, this module you don't want, you want just block. Okay, if you don't know what that is, search for my website xahlee.info. Xah Lee Wolfram programming local variable. You'll find the page that explains the difference between module, block, and width. Okay, so we should use block. Okay, let me just code it, because if I keep explanation, this will never finish. Let me code it for 10 minutes and then we can explain. So this is a definition of a function by a pattern. So hypocycloid animate. So you need, so then you need the documentation, because what are the parameters? So we do need the documentation for the hypocycloid. Okay, so yeah, so okay, so it's pretty, copy that. Okay, delete that, go back here. You kind of need the documentation there, and okay, documentation that hypocycloid. Okay, so well, okay, so one of them is optional. Okay, so let's just say that generates an animation that generate a list of graphics that trace out hypocycloid by means of roulette of two circles. Now that's two verbose and technical. Let's just say by means of by rolling a circle inside another. Okay, this is more practical wording. Before that, it's, if you say roulette of two circles, that's more academic. So I don't want that anymore, because the society moves on, it tends to be less formal. Like you don't need those jargon words. Rolling two circles is perfectly precise and clear. Rolling a circle inside another. Okay, I mean, it's clear enough. So that is that function does that. Okay, so actually you should, okay, so actually delete that. Okay, because we renamed it. Okay, so there is more here now. Okay, so hypocycloid animate. So this generates a list of graphics that trace out hypocycloid by rolling. This is lowercase hypocycloid by rolling a circle inside another. Okay, then you can give a optional tmin to tmax and tstep. Start and stop at the range tmin, tmap, tstep. Okay, so that is optional. Now okay, so now actually, so here are the parameters. A is the radius of the fixed circle, B is the radius of the rolling circle. Okay, A greater than B, Okay, actually A could be less than B. A greater than B. Yeah, A could be less than B. H is the distance from the tracing point to the center of the circle. Okay, that's important. Let's put that there. Special options are number of frames. No, we don't want that anymore. So you see, we used to have an option because when you are writing a package, it's nice to have like a option, like more formal, like every function has options. But if you are just writing the code directly, you don't want the options. You that would be just controlled by the steps here. Okay, so if you want number of frames is controlled basically by the step. They are the same thing, but using different ways to express it. Hello from Iceland. Oh, hi. Don't matter. Name don't matter. Are you Iceland? Are you Merkavert by chance? I don't think you are Merkavert. Merkavert is our friend from Iceland on Xah Discord, but I guess you are different. Hello. So, are you starting to learn Wolfram language? Have you ever used it before? Okay, so let's go back to this. Okay, stop. So right now we are doing the inline documentation for this, and also we are like actually designing the function parameters. I'm a different Merkavert. Okay, that's cool. Okay, so delete that, and other options are passed to graphics. No, we don't want to do that anymore. Okay, control the number of rotations. Okay, yes, that's the number of rotations. Should I mention that here? Yeah. Okay. If not specified, an internal algorithm will figure out the number of rotations so that the curve is closed. Oh, that's wow, that's extra touch. You see, this is actually significant. So I wrote an algorithm that you need to determine, like you are given a radius of the large circle and given a radius of the smaller circle. You can assume the larger circle has radius 1. Okay, so the smaller circle is a fraction. I mean, it could be actually not a real number, but I mean, if the radius of the smaller circle is not a real number, then I think the curve never repeat. It never repeats. Okay, I think you need to prove, but I'm pretty sure. Okay, but anyway, so but if your smaller circle's radius is a fraction of the larger one, then you can determine how many, like what's the range, like T min to T max, like how many rotations it needs to go before it repeats. Okay, so there is that magic number. So where did I say, so in my code, it's encoded somewhere. Okay, I don't remember. So anyway, that's okay, so that's a nice thing. Okay, so also remove that because we don't need the number of frames thing. Okay, and also you have this situation, 0, T min greater than 0, T max greater than T min less than infinity. Okay, then you got an example. Well, no, we don't want this. We no longer want number of frames. Okay, so so that's kind of a example. Okay, so this comment up. Okay, it's kind of tedious so far. So you see, this is a usage inline documentation string. Okay, and here are 2 examples of actually calling it. The first one, this creates an asteroid. Okay, The second one creates, 1 and 2 over 5. I'm not sure. Some, some other thing. So now we are, now we understand the parameters. Now we are coding. Okay. So what you want to do, first of all, let me write a few things. Okay. I want to clear up the parameters. So let me just show you so that, okay. So first of all, wait. Okay, so first of all, if there is no parameters, well, what happens if there's no parameters? If there is no parameters, you could say 1 and let's say, okay, 1 over 4. Okay, 1 over 4, then that is 0. Okay, so if there is no parameters, let's just draw the asteroid. Okay, now if so, then you need to give a parameter, right? Then that would equals to, oh god, how do you do this? Okay, this is more difficult than I imagined, because I was imagining I can just explain this and we'll have the code and we are done in 30 minutes. But actually now I run into a situation that you see, I haven't explained this part. Okay, the options we don't need. Okay, because we don't want options. So you first of all, you need to think about what you want to do. So what we want to think about right now is what kind of forms of this function accept. Okay, so if there's no argument, that's one form we accept. Then we just make it do the asteroid. We just assume the default parameter. Okay, then we also can have this form, right? Yeah. And what else? Is there some other? Well, there's, you see this function. Okay, it does require 2 parameters. Okay, well, kind of. So the first parameter is required because it specifies the size of the circles and the distance from the tracing point to the center of the circle on the rolling circle. Okay, so the first parameter is required, but in fact you can reduce the 2 circles into just 1 radius to their fraction. Like you can reduce them to a fraction. Anyway, so that's the first parameter. What about the second parameter? The second parameter is they basically control the starting frame and ending frame of the rolling circle, right? And then the third argument, I mean the third part, is the number of the steps. Okay, how much steps you do each time. So the steps can be omitted if you see, if the radius ratio is a rational number. Otherwise, because if it's getting complicated, if the ratio of the 2 circles is rational number, then you can figure out actually the start and the max, the range. You can figure that out. And okay, the step, you can always figure out the step, like always just generate 80 of them. Actually, no, it depends on how many, like some of these needs a lot of steps to be smooth. Okay, do you guys know what I'm doing? am I like getting too complicated? Because some of these parameters, let's see, where is today? So we did this today. Let's see that. You see, now better picture. You see some of these, for example, let's say that one. That one takes a lot of turns, 3, 4, like it could be like you have to make 100 turns, so even 1,000 turns, okay? So some of these parameters really requires you make 1,000 turns. And for those that requires 1,000 turns, the number of steps needs to be very small, like 0.1. So effectively, if you want a smooth animation, you're gonna have an animation with, 1,000 frames. Okay. Now for the simple one, like the asteroid, you just need 40 frames. That's smooth. But for some of these, potentially you can have like 10,000. You need 10,000 frames because they need to turn, like 10,000 rounds. Okay, so right now we are thinking about this parameter, part. The beginning is easy. We can always start at 0. Now the T max, the maximum, when do you stop? That needs to be figured out. Okay, so you can give a value, it won't work because for all these cases, if you just say 0 to 2 pi, they don't draw nothing. They just stop right away. Like you don't get a curve. You don't get this pretty curve. You just get like a stroke. So well, anyways, the T max can be figured out if the radius, I mean if the ratio of the circle's radius is a fraction. Okay, then steps can always be figured out. Okay, so what we need to think about now is about the design of this function. Like what do you require the second parameter? That's the question. You see, if you do not require the second parameter, meaning that people can omit it, then you need to figure out what is the second parameter. But you can't do that. Well, okay, you run into a lot of issues. One of them is that if the ratio is a real number, not a fraction, then basically you just have to like create a magic number when to stop because it never repeats. Okay, that's one issue. When the ratio of the two circles radius is not a rational number, you have to magically figure out when to stop. Okay, that's one issue. The other issue is that when you have a situation where you have to figure out how many turns they stop. Okay, when that is large, you see, I don't think you want the function to automatically generate like 2 billion frames, because your Wolfram language is gonna crash. So when so you have to say like some kind of maximum number of frames, even though it doesn't complete, like when you have this complicated case. Okay, so when you design this, you came upon these issues. Do I make sense? Are you guys, like, some of you know what I'm talking about? Name says, enjoying the stream, thanks. Geometry visualization is really cool. Thank you. Hi, Melchi. Okay, we kind of got an issue here, but let's see what I did 30 years ago. Because 30 years ago, because usually I think a lot. So 30 years ago, let's see what we did. So it will automatically You see the okay, so indeed it automatically generates the T-min, T-max. The optional list T-min, T-max, T-step control number of rotations. If not specified, an internal algorithm will figure out the number of rotations so that the curve is closed. Right. But if you see the ratio of the radius is not a rational number, you cannot, the curve is not closed. So what do you do in that situation? The documentation didn't say. Okay, that's a flaw. Okay, so now let's look at the code. Okay, now let's, we haven't decided what are the parameters yet. So it's a bit, we haven't decided what to do there. So let's comment out. But what we, okay, so let's comment out. So let's look at the code, what we actually do. So if T range, let's see. So if T range is not given, then we, okay, so fuck. Is this interesting? I think, this is not good because I talked for 10 minutes on very technical details. I don't think people are interested. And we haven't actually talked about the more interesting stuff of how do you actually figure out. That's what people want to know. How do you figure out at any time where is the circle? Okay, so like at given moment, where is the circle and where's the dot? So those are in this, people want to know where is the code. So anyway, the formula for this hypocycloid curve are this cosine sine, okay? But the part where you figure out which position it is this one, okay? Okay, well, you guys don't know what I'm doing because if you are not familiar with Wolfram language, then you don't know. So, okay, so what we're gonna do here? Well, yeah, so what are we doing? So you need to simplify the code, okay? Yeah, so previously we assumed, so if we assume this is optional, so you see, if this is optional, so if we get automatic, that means by default, if we get that default, then what we do is you get the numerator. Oh, okay. Zero to rationalize. Okay, so you just force it into a rational number. That's what we did. You see. So what happens when the ratio of the circle's radiuses is not a rational number? Because if that's the case, the curve will never repeat. Well, if that's the case, you just force it into a rational number, like closest rational number. That's what I did here. Very good. Okay. Yeah, so you see that's what we did here. That's the code. Yeah, okay, so that's one thing. So this block deals with when this two and beginning and start and stop and steps is optional. Okay, so How you guys doing? So actually, I'm thinking of stopping. How long have I been talking? 45 minutes. Okay. Should I continue? Actually, I should. I should continue until I have like, complete code so I can paste it, people can use it. I should. Yeah. Okay. Let's continue. Okay. So let's continue on that. Okay. That's what okay. Okay. So T min, T max. Okay, so let's focus. Let's go back to the design of the function parameters. Okay, so what I used to have is this thing. Okay, so this is what I used to have. Now let's redesign to be simpler, because so when there's no parameter, just do that. When there's that parameter, do that. Then wait, when there's that parameter, what you want to do is yeah, so actually here can we actually bring it here like that? T min is always just 0. Okay, so forget about T min. T min is always just 0. So forget about that. Forget about region. Let me just fix the code quickly. Okay. What does this now? Okay, so T min is just always 0, and T max is going to be fascinating. Rationalized times 2 pi. Fascinating. Okay. Okay. And T step is, what is T step? T step is T max in minus T min. Okay. So and so actually you need the A there for this to work. Okay, so you need a few things. Okay, so okay, so you just need to define these 3 values. Okay, T min, T max, T step. You need to define them, and we can do that by T min is simply 0. Okay, and T max is like do I make sense? Is it good? T max is like that. Okay, T min is like 0. T max is like, actually you need to take rationalized b. You need to take numerator of rationalized b. You need to take, I think you need to take consideration of a. You are missing a here, so maybe it's like that. Okay, do you guys know what I mean? Maybe you don't. So going to bed. Tune in next time. My first time seeing Wolfram, but very interesting. Thank you. Good night. Good night. Okay, so we continue to do this. Yes. Okay, then you got t steps. Let's say t steps equals to t step equals to the numerical value of, okay, let's forget about numerical for now. Okay, so that okay, so number of frames, we don't need that, we don't have that values anymore. So t step is just by default is what is the default number of frames? 41. Okay, let's just say 40. Okay, yeah, we don't have the number of frames anymore because we don't want it. Okay, okay, so number of frames 41, so t steps is just divided by 41, which actually creates 42 number of frames. Wait, okay, so anyway, so let's just do that. Okay, it's so don't do that. What is that? Okay, that's what this will do. Okay, oh wait, it's already there. Yeah, it's already here. So 1A, B, and H. Okay, so this, you see, that defines. So if you don't give the second argument, then it will actually create the second argument. Like here, you just call this this. Okay, so this part delete. Okay, so you see, if you do not give any argument, then you will call that. But if you only give one, this argument, then it will create t min, t max, t step. Okay, and t min is always 0. Okay, so you don't need t min. T min is always like 0. Okay, then t max is numerical b. Actually, let's remove that, b over a, then the numerator, then times 2 pi. Hopefully, I think that's that. Then t step is t max divided by t max. Now be careful, the capital letters, so we are using lowercase, so t max, just t max divided by 41. Okay, so actually you don't need that because now because it's just there, t max, so you don't need that parameter anymore. T max is just that. Okay, you only need one local variable. In that case, just put it there. Okay, in that case, it's just that. Okay, one local variable, Tmax. Tmax is defined by b over a and rationalize, and then times 2 pi, then take the numerator. Yeah, that's how many number of turns you want, okay, kind of. Then you just call, so after the block of code, yeah, then you just call this. Tmin 0, Tmax is Tmax, and then the steps is Tmax over 41. Okay. After 20 minutes, we did that one. We're trying to simplify the code. Okay. Now here, now the full code here, let's highlight the opts. Okay, now we got too many highlights. Action patterns, option, you don't know, you guys don't know what I'm doing, but just let me do it. Okay, remove that. And options, yeah, it occurs there, so delete it. Okay, now go to the options. You don't go to the options, you don't want this anymore. Okay, so delete. Okay, we remove that option, and then we got this number of frames. Let's also remove it. Okay, but before, you see, we were defining the Tmin, Tmax, Tsteps. Now we don't need that. We don't need this block of code anymore. Delete. And now, you see, now hold on a second. So Tmax, so number of frames, let's remove the number of frames variable. So you see there's a local variable n of frames. Let's see if it's still somewhere. No, so delete that. Okay. And the Tmin, Tmax is also no longer needed. So this second parameter is no longer needed. Okay, so but actually it is needed. So let's modify that. So it's gonna be, let me show you. Okay. Okay, so instead of that, now it's gonna become like that. So except we need these matches. So these are patterns. That means a pattern of a list of 3 things. Each thing can be anything. That's a low line. And we name each one by, the first one is, we name it Tmin when it matches. The second one we name it Tmax. The third one we name it Tstep. So this, again, it's a list of 3 things. It's a pattern, okay? And each element, we name it when it matches, okay? So we don't need this, so, but this part originally, this part means this is one thing. It's a pattern, okay? It's a pattern of anything. It could be any. It will match any item. Except the item must be a list. The item must have the head list, okay? So this part means it will match anything, but it must be a list. And then we name it T range, okay? But, and also this part will also match 0 item if there's no item. In that case, it will return, it will provide this list of 1 value automatic symbol, okay? That's what this means. So, but anyway, so now we just delete that, make it simpler. We made it into this form, okay? So now whenever you see this pattern, hypocycloid animate, at least 3 things, another list of 3 things, what you do is then you do this, okay? Okay, we are still in the process of simplifying the code. We are making a lot of progress. Make a backup. So let me code again. So this is the deep Wolfram language coding. Okay. So Tmin, Tmax, do we have Tmin? So before we do anything, let me put the code back. Syntax correct, show in browser. So we are looking back at the page, Asteroid, this animation, that's a code we are writing, and here's a code, okay? That's we are currently working on, okay? So this code, let's pop it out again, make a backup, pop it out. Okay, so we clear the symbol, then we define the usage, make it clear to people what it's actually doing. Great. Then let's shrink it. Well, then we have this. This is like this is a case for asteroid. Okay, and what about this one? This is some hype. We don't know what this shows. Okay, we don't know what it looks like. But so those are, let's move it to the bottom. Okay, let's move it to the bottom so that those are actual examples. Okay, now go back to our code. Now go back to defining our code. So when there's no argument, then just do that. Okay, when there is one parameter, then you do that. Okay, so yeah. Okay, then otherwise normally it should take two parameters like this. Okay. Wait, let me define another one. So if there is two parameters, but the second one only has two values, then you do it like hold on a second, let me show you. Okay, then you do it like t max minus t min divided by 41. Okay, so if user gives two arguments, but the second argument only has two items, then you automatically transform it into the second argument gonna have three items like that. Okay, then the final, like the most general, the form. So when this pattern is found, then we do this. Okay, we want to do, so let's look at the code. Okay, so now comma space, change that for easy reading. Okay, okay, and let's highlight the keywords. Okay, just highlight the keywords. Okay, then oh, you need a margin, you see. So what is margin used for? Margin is for, yeah, when you actually finally plot, you want a little room outside of the circle so that it looks nice. Okay, that's what this margin is. And this can be simplified. Let me just show you. So replace margin by just one, 2, 3, 4. Let's say 3. Run it. Yeah. So that you see. So this margin, so this part can be simplified as just multiply that. Okay, yeah, let's do that. Okay, so yeah, so simplify the code. Okay, so we are close. Okay, so you got the margin. Then you got, okay, margin is kind of just a value. Now it HB, AB, H. So here is T max, T min. And here you don't need to compile. Okay, compile is like, I don't think you want to, you know, so this code is written 30 years ago. Should I still use compile? You can look at Wolfram language, creates a compile function that evaluates expression assuming numerical values. Okay. You see, basically the purpose of this compile is just to make evaluating this expression faster, basically, this sine cosine. But today, I don't think you need it. You see, because if you use it, then it can get complicated. Okay, so actually, let's, let's not use compile. Do I still make sense? So this is like a function. Okay, so this is a function. Let's see. Yeah, it kind of creates a numerical function. We can leave it. What? So here you basically you are doing okay, so well, so what you're doing is that and this curve function, no, let's see, can we color it? Yeah, you just need one. Okay, you don't need two. So this curve function, make them one. You can just say paraffin, and let's not compile shit. Okay, and function of x, yes, that's a function of x. Okay, so that's your parameters. That's your actual the function. What the function actually do? Okay, and you can you don't need those are small numbers. You don't need compile. Okay, so you just need to power function is a function. Okay, function okay, a function of one single value t. Okay, and in fact you can just remove t by that. Okay, that's so this defines a function. Okay, this defines a function. This function is just two a single variable, but returns a vector. Okay, so you don't then you don't need this compile xy. Okay, delete. Okay, then you delete. Okay, you simplify a simple function. Then this then you need actually put that there. That's your function. Power function. Then your function needs to be mapped here. So your function is point power fun. Wait. Wait, that's duplicate. Okay, so function. So what is the point? So each one is a point. Okay, I think that will do. Do I make sense? Is anyone still watching me? Like understand Wolfram language coding? Okay, not many. So anyway, so oh God. So thinking about this live stream, I've been doing for 70 minutes. Oh God, coding takes some time. Okay, that's true. So this will generate a bunch of lists, and can we actually just run it? You know, instead of thinking about, oh God, then you got the center. Why do you need a center? Okay, you need the center because then the last frame you kind of don't need. Yeah, so you see, so we got lots of things going on. But will the code run? I'm pretty sure it will. Okay, let's copy the code. Let's just try to run it. Okay, so you see before it was like that. Fantastic. Now copy all. Now select all, paste it. Okay, you got some issues. You see those red? Yeah, those red, that means you got a problem. Wolfram Language Notebook is great. It helps because now you see you got a problem because the red oh you got more than one problem. You see the red is already the pattern, so you don't need inside they are not local variables, you see. They are already part of the pattern, named pattern, okay? And also this equal sign is incorrect. That should be just that, okay? Yeah, so copy all. Let's see, try it one more time. So that is that, that is that, that is that, and then that is that. Let's now make it one line, okay? Now copy all, select all, paste. Now, will it run? If I run this, will it create animation? Possibly it will. Okay, I'm pretty sure it just let's just try it. Okay. Okay, we got an error. You see, you see, you see the circle seems to run, but the dots is not working. You see, the circle is running, they are turning, they are turning, they are turning, but you are missing the dots. Okay, so we can fix that by point list. So you see this, okay, so the point, we got it wrong. Yeah, so okay. I'm not sure why. Let's do it again. Shift enter. Fantastic and beautiful. Fantastic and beautiful. You see, we cleaned up the code, and now we are doing it correctly. Okay, now, okay, so fantastic. Now, hold on a second. Now, let's just list anime at that and copy all, select all, paste. You just show animations. So the first one is Asteroid. We are familiar with it. Works fantastic and beautiful. And now we have improved the code. The second one is this. You see this now here is more interesting. You see now you cannot quite see what the curve is because there are not enough frames. Okay, so this is when you need to, okay, we run into an issue. You see, if you say 80 frame, you see, you can't just say that. If you say that, then it won't create enough turn. You see, now it's nice, but it stopped. You see, so we got a design actually. So we got a problem in our function design. You see, you can't just, because you know you need a program to figure out how many turns it'll make to complete the curve. So if you omit the second parameter, it will figure out how many turns to do that. However, but then you don't have the number of frames, you see. So, but if you automatically have a default value for number of frames such that each turn has 40 frames. So if you make 5 turns, that's gonna be 5 times 40, 200 frames, right? But if you do that, then the problem is for some of these parameters, let's say 2 over 91, it's gonna make it has to make 91 turns. Then 91 turns times 40 frames, you're gonna have 90 times 41, right? Think of, you're gonna have like few thousand frames, so that's kind of problem. So that means, so the issue is like about figuring out the automatic parameters, the default values, like it's about the design of the function. That's a headache because ideally you don't want a separate option that says how many number of frames. Anyway, we got a code. Okay, so we got a code pretty good. Let's put it back. Syntax correct, showing browser. So when my website is fixed, you go to xahlee.info, spatial plane curves, visual dictionary of spatial plane curves. Search for it, you'll find asteroid. You got this animation, then you got this code. You can just copy. So that's what we did. But we didn't. But we need to make a backup. We need to work more on this. So this is not the final code. But I think that's it for today. Melchi says, have to go to bed. Okay, now. Okay, good night. Okay, I think that's it. Yeah, so we, yeah, so how long have it? So it's 80 minutes coding, okay. 80 minutes coding, it's pretty good. The thing is that we have to figure out, quite a few things to figure out. So it's pretty good. And the code is not the best yet. Actually, there's quite a few things we need to do. And yeah, there's quite a few things. Okay, why is this range list? Do we need it? Okay, we kind of do. Okay, so we got a code, but we haven't gone through it completely yet. There is improvements to do. Okay, and but so far so good. Yeah, and we need to figure out the automatic parameters. Okay, do you guys know what I'm saying? It's a bit complicated. This is about designing of the functions API, the functions parameters, such that the user do not have to figure out, it should be able to automatically figure out how many turns this thing needs to do, and also automatically figure out how many number of frames. Yet it's not so like overwhelming. It's not like thousands of frames. But also, you don't want a situation like this right now. I mean, so this one, for example, it did, it figured out how many turns and frames, but the frame number is not enough. Okay, so maybe what we can do is that make the frame number by default. I mean, compute it, like how many you need. Then put a maximum limit. Yeah, that's what you should. Like the maximum number of frames is 400, let's say. We can actually code that. So we can code that by like right here. So if, so T max, yeah, so actually it's about this T step. So that would be here. So there. So T max divided by 41. No, you need to, so let's actually, we can fix this, okay? So what you want to do is T max, okay, then T step. Okay, now T step, you can say that. Okay, that's what we have right now. T step is just equals to that. But that creates a problem because for some of them, such as this, the number of steps is not small enough because it's not enough number of frames. So what you want is wait, Tmax. So that's how many number of turns. Okay, no. So let's define another. X turns equals to something, okay, like that. X turns equals to that. Then T max equals to X turns times 2 pi, okay? So that's the number of turns you need. And this is T max. So step will be equals to, yeah, step will be equals to, let's say T max what is it, divided by 41 divided by number of turns times 41. Okay, fantastic. You see, can you guys see what I'm doing? Like, does it make sense? Lots of technical details, you see. So this would be perfect. So if given, if the user doesn't say how many, start and end points, then you figure it out by computing the number of turns, then computing the Tmax would be 2 pi times number of turns, right? Then the step would be Tmax divided by turns times 41. That's right. So for each turn, you want 41 number of frames, something like that. And wait, but if it's over 1,000, then don't do that. So you want to say max of, okay, maximum of, yeah, maximum of either that or let's say 400. Okay, you don't want that too many. Okay, so that, see, fantastic. So copy all. Now go here, select or paste, shift enter. Let's see, will it do it? You see, the trick is the second one. Let's play it. Now is it, wait, oh shit. Okay, no, we didn't do it correctly. Oh, you don't want max, you want the min. The minimum of, oh wait, so actually, so divided by the max. Okay, I think that divided by, right. Okay, copy that, select or paste, shift enter. Okay, that one we already know. Now the second one, oh god, the second one is not showing. Shit, no good. Oh, it's still computing. What? Okay, now is it using too much memory? It looks like it's froze. Oh, there it is. Fantastic and beautiful. Can you see? We fixed that. Fantastic and beautiful. Automatically figured it out. Perfect. So 400 is too many frames, okay? We don't want 400. Let's say 200. Automatically figured out. And also we want a numerical, okay? So let's say n, copy all, okay? Fantastic. We did this perfectly. Shift enter. Let's run it again. Okay, the first one is done good. Now we wait for the second one. The second one is done fantastic and beautiful. Perfect. Okay, that's it for today. Thank you guys for watching. See you next time. If you like my stuff, donate. Okay, go to xahlee.info, my website. At the bottom, you can find my PayPal and Patreon and donate to me. Okay, that's what makes the work going. Okay, so that is good. So in fact, we can actually make it, we can adjust this a little bit more. Let's say 250 frames, okay? And put the code back, syntax correct, showing browser. So in a few days, I'll update my website. So the code will be all here and correct. Okay, now the code is actually taking too much space. So actually, anyway, there's needs to be more to be done with the code. Okay. Oh, and we need to generate this one. So this one is the rolling circle is 3/4. So actually we can do that by just copy this, copy this, copy. So paste it. We don't care about the second part. Figure it out yourself. Delete. Then the rolling circle is 3/4. Right. And do it. Okay, why is it? Okay, so there it is. Oh, so wait, okay, no, wrong. This is not the right graphics we are looking for. Although it is a true hypocycloid, but circle radius, the rolling circle radius 3/4. Wait. Oh, then you need to also say the radius. I mean the distance from the bar to that is that. Okay, do it. There it is. Fantastic and beautiful. Bye, guys.